and the first thing we're going to talk about, hopefully somewhat familiar with, and if not, we're going to talk about it now, define it, work with it, is the idea of a ratio. Oh, how did I do that? There we go. And a ratio is a comparison of two quantities. Its quantities need to have the same units. So if you kind of look here, feet and feet, all right, these are feet and yards. We want to convert those. We want to make sure that they have the same unit. So when it refers to the same unit, these have the same unit, these do not. So we would want to convert one of these, right, so that they do have it. We're comparing kind of apples to apples. And the big thing here is ratios can be expressed in three different ways. The most obvious way, you can see it here in numbers 1 and 2, are with a fraction. So one of the ways you're going to write down as a ratio is just a fraction. So we'll just put this as A over B. Another really, really common way, you've probably seen this for varying things, is using a colon, A to B. So whenever we see this little colon right here, that is read as the word to. So A compared to B, A to B. Because that's what it means, you will also just see it written with the word A to B. All right, it's basically a comparison of two numbers. All right. The most common way that we're going to deal with it, not all the time, but most common, is definitely with a fraction. So if I ask you to simplify these two ratios, as long as they have the same units, it's really just us reducing a fraction. All right. So if we went ahead and did this here, looking at 12 and 15, you're just going to identify you would have called this your common factor, your greatest common factor. That's basically the biggest number that goes into these three or these two. I said 3 because that was on my mind here. Our greatest common factor is 3. That's the biggest number that divides evenly into both of those. So since 3 is our common factor, 12 divided by 3 is going to be 4 feet. 15 divided by 3 is going to be 5 feet. So that reduces down to be 4 feet for every 5 feet. All right. All right, when we come to number 2, if we are wanting these to have the same units, we want to convert one or the other right here. It doesn't necessarily matter which one you convert. I think in this instance, converting yards into feet is probably one we're most familiar with, hopefully. How many yards are in or how many feet are in a yard? Make sure everybody knows that. Yeah, Armando. Yeah. So for every 1 yard, there's 3 feet. So if I have 6 yards, that means I have 18 feet. All right. That gives us this idea of the same unit. And then simplifying that is really just reducing a fraction. The greatest common factor, or the largest number that goes into a 16 and an 18, is a 2. So you're just going to divide each of those by a 2. So that's 8 feet compared to 9 feet. All right. So nothing revolutionary here. Just kind of understand comparison of two numbers. We want to have the same units, and we can write them any of these 3 ways. All right. And then that's kind of the simplest, easiest way to kind of set this up. Then we get to the idea of a proportion. So don't get these mixed up. A ratio basically is one fraction. It's a comparison of just 2 sets of numbers through a fraction. When we then jump to what we call a proportion is 2 fractions, 2 ratios, all right, that are equal to each other. All right. What that means is, so kind of set this up over here. If I took A over B, that's one ratio, that's one fraction. And I took a second ratio, so we'll go C to D. So we have one ratio here, one ratio here, one fraction, and another fraction. When those are set equal to each other, that's what we call a proportion. In order to solve a proportion, the cross products in a proportion are equal to each other. Cross products just mean that if I kind of crisscross, A times D would have to be equal to B times C. I'm going to show you what this means with numbers, and then we'll do these with variables here in a minute, and this is why we're going to be able to solve these equations below. So let's say we took, let's do something that's not too big, 4/10. Reduce that for me. So reduce that down. when we reduce this, 4/10 reduces down to b, so it should be equivalent to what? What is it? 2/5, 2/5. All right. If these are in fact a proportion and they're equal to each other, they're cross products. So notice now what happens. If I crisscross, 5 times 4 is 20. 10 times 2, not coincidentally, is also 20. So if I have a proportion where I have two equal ratios, this should always happen. Their cross products are always going to be equal to each other. All right. And in this case, it was 20 and 20. All right. So in terms of solving proportions, you're going to first cross multiply. Be careful if we ever have two terms. We'll get to this in a minute. We're going to need to distribute a little bit. And then we're also going to revisit these a little bit, these quadratic equations from back in the day. Remember how we had to do either factor, use square roots, the quadratic formula, kind of all that fun stuff from back a long time ago. All right, those can also pop up. All right, so go to number 1. We'll solve these. You'll find these pretty nice, I think. This is a proportion, and the reason it is a proportion is you have one fraction here, you have one fraction there, and they are equal to each other. So it's two ratios that are equal. And what we just said is when that is the case, the way we solve these is by cross multiplying. So I'm going to multiply 3 times 2x. And then I'm going to do 9 times 2. Now, eventually we'll kind of skip that step where we're going to actually write it. But I want you to kind of see what we're doing. The 3 and the 2x get multiplied. The 9 and the 2 get multiplied. When we do that, this just gives us a simple little 6x. And then on the other side, you're going to get an 18. From there, it's just solving a really, really simple little equation. All of us would know to divide by 6. And then that x value is going to be a 3. I won't do it with all of them, but let's now take this 3 and plug it in just to kind of prove this. 2 times 3 would give us a 6 right here. And then hopefully we would all agree that wouldn't 6/9 reduce down to be 2/3? Okay, so that kind of confirms that this is in fact our answer. Now, the ones that you want to be careful of is here. These are going to be the ones we eventually get to quizzing and testing, things like that, that I see the most mistakes on. When we cross multiply here, notice how there are two terms. Because of that, you need to make sure that that 4 gets distributed. Kind of revisit our old distributing rules. When we cross multiply here, you're just going to get an 8y. Now, long term, if you can distribute right off the bat, feel free. Eventually, I'll probably graduate to that as well. But right now, we're going to write it as a product of these two. So we understand the 4 needs to get multiplied by the y, and the 4 needs to get multiplied by that 3. So the 4 and the y would make 4y. The 4 and the 3 is going to make a 12. And then, no, that looked like v8y. There. And then that's our equation. All right. We just go through, solve that. We've had a ton of practice solving equations from our last chapter. So subtract that 4y over. Move this down. Uh-oh, do that. And divide by 4. And our y should be 3. All right. All right, so with that, actually, we want to do 3 together. Try 3, actually. Do the first step or 2 and 3. See what you think. See what we remember. All right, first things first. If I revisit number 1, okay, when we multiplied right here, when I took my 3 and multiplied by 2x, we really only have two numbers that get multiplied together. The 6 is a product of 2 and 3. And so there's only one x in these two terms. We just get that 6x, and the other is an 18. What's a little different now in number 3 is when we cross multiply here, we still do the 2 and the 6 to make a 12. But when I do an x times an x, what is x times x equivalent to, Assad? Good. That gives us an x squared. All right. Then that's going to equal, crisscross here, the 8 times the 9 is a 72. If you recall, this is a quadratic equation. So we spent a good part of first semester solving quadratic equations when we had that power of 2. There were 3 ways that we could solve quadratics. All right. The way that we're going to approach this one, at least the initial part, is if we just have this single x squared, kind of solve this the same way we would an equation with this is just an x. I'm going to divide by 12 so that these would cancel, and I'm going to get x squared is equal to a 6. Then, anybody remember how we got rid of squareds? If I ask you to get this all by itself, Julia? Good. Remember the little square root right here? That means I have to take the square root of the other side as well. And then we would say x is equal to, and then recall how whenever we took the square root, it always created both a positive and a negative solution. So our answer to this should be a positive and a negative, and then root 6. Think back when I had a root 12. You don't necessarily need to write down this root 12, but remember how we could simplify that into a 4 and a 3? The square root of 4 is a 2. We leave the 3 alone. If that's possible, and it's not in this case, there's nothing you can do with the root 6. But if we ended up with these again, we need to kind of recall how we simplify a square root. All right. Now, in this case, we can't. So our answer is the kind of weird x equals plus or a minus root 6. All right. So one of the ways that we could solve quadratics is what we call the square root method. And that's what we did for this one. All right. Number 4, do the first step in 4. See if we can do that correctly. Okay, and then don't go too far, just in case we don't remember all this, because this is going to take you way back. The part we should know is we're crisscrossing here. So the n plus a 1 gets multiplied by the n, and then the 4 and the 5 get multiplied to give you a 20. All right, so that part we should know. The second step, again, hopefully we would know, is we want to distribute. So an n times an n, like Assad told us with the x, should be n squareds. And then an n times a 1 would just be a 1n, and then that would equal a 20. All right, from there, we got to remember some old stuff now. All right, to me, the easiest way is the way that we just did it. So don't write these down. Quick little refresher. If I have something simple like this, we kind of just did it. We can take the square root, and we would say x is a positive or a negative 6. Those are the two numbers I could square to get 36. But notice how there is just an x squared term. When I would give you ones like this, x squared, let's do minus 10x plus 25 equals a 0. Notice how we now have this middle term. We would call it a linear term. It has that power of 1. This method doesn't work anymore. The only way that method would work is if we did the method that nobody really liked and that we were probably least good with. Remember the whole little completing the square here? Whatever I added here, I'm going to have to subtract away right there. That was probably the one of all the ones we did that people liked the least. All right, the method that was best for these, remember how we would factor? If at all possible, we always said factoring was the easiest. So we would look for the numbers that multiply to be 25, but add up to be a negative 10. And those would have been, in this case, be x minus 5, x minus a 5. They multiply to give us this. You add them, they're going to give you this. We also had, remember this bad boy from way back in the day? The good old-fashioned quadratic formula. So those are all the different ways: factoring, quadratic formula, or the square root method. So when we look at this one here, the fact that you have this term here means we probably don't want to do the square root method. That means you're completing the square, and it's just the one that we probably were least good with. So in this case, we probably either want to factor or we want to do the quadratic formula. However, before we do that, we always wanted to make sure that everything was set equal to a 0. So that's important. All right, another old idea that we haven't had to do in a while. So the thing we need to do here is we want to take this 20, we want to move it over to the other side. So we want to get rid of it from that side. That would mean subtraction. And then I'm going to want to subtract 20 from the other side as well. That gives us the 0 that we need. When we look at this negative 20, is there any other constant over here that we could add the negative 20 to? No. So you're going to leave that n squared first. Then we want the 1n, and then we want the negative 20. This is now your decision. Again, you could do the square root method, which is the completing of the square. I would strongly recommend not doing that because that we weren't very good at necessarily at the very end of this chapter. So I wouldn't necessarily do that. If it factors, we all agreed at that point in time, whether you remember or not, that was pretty much the easiest route if possible. And if that doesn't work, you've got to use the good old-fashioned quadratic formula. So when we look at this guy, what we are hoping for is there are two numbers that multiply to be a negative 20 and would also, when we add them, give you a positive 1. If you can say, yes, I know two numbers that do that, then we would factor. If that is impossible, then you've got to do the quadratic formula. So what do we think? Are there two numbers that multiply to be a negative 20 and add up to be 1 so that we can do this? Or are we stuck with doing the long quadratic formula? Armando?
I got 5 and 4.
Say that one more time.
5 and 4.
All right, so what's 5 times 4, Armando?
20.
We need it to be a negative 20.
5 negative.
All right, so now negative 5 times 4, does that give us a negative 20?
Yeah.
All right, now add these, Armando. What's that give us?
Negative 1, so then it's the negative 1.
All right.
I think it isn't like when you put it in like the actual equation, isn't one have to be the opposite?
When we get the answers. Correct. We had factors and then we had solutions. So what we want first is the factor. So Armando's it's good. He's kind of walking us through all of this. He first picked 5 and 4 because that gives us a 20, but we wanted to be a negative 20. So then he understood he needed to make one of them a negative. So this now gives us this negative 20, but do these guys give us a positive 1? No. So then that's when he again said, all right, well, he now understood, let's make the 4 negative because these will still multiply to be the negative 20. Do these now add up to be a positive 1? Yeah. So those are our what we call factors. So the first thing we would have done is we would write this as n plus 5, n minus a 4. That equals a 0. Those are our factors. And then our solutions, I usually would highlight one of them and ask you what value of n right here would make this factor equivalent to a 0. And you would tell me that would be what value of n? What was it, Armando? Yeah, negative 5. So that would be one of our solutions. And then I'd highlight the other one. What factor or number would make this factor 0, Julia? That's what? Good, positive 4. So those ends up being our two answers. All right. We won't do as quite as long and ugly ones as we did back in the day when we were focusing on that. But just kind of remembering simple little square root methods, simple little bit of factoring, and possibly a quadratic formula, things we want to kind of recall. Okay? All right. Next thing we want to get out of this section are little word problems. And these are the ones that maybe you've seen before. All right. So go to the next page, number 1 here of the word problems. All right. So it says Myra's Meatloaf uses 4 pounds of hamburger to feed 6 people. The question then is, how many pounds of hamburger will need to be used if there's going to be 15 people? All right. So there's a couple different routes we could take here, but we're going to be dealing with this idea of a proportion, just like we have right here. All right. So fraction set equal to another fraction. So the way we're going to set up these fractions is just kind of going through with reading these sentences. So if I have 4 pounds of hamburger, so we're going to write that. is going to feed 6 people. That's one ratio. The ratio, again, is one fraction. A proportion is 2 ratios set equal to each other. We are then going to set that up because we're going to be setting up our own proportion. And we're going to set up another fraction. So the important thing here is what I want to know is how many pounds of hamburger I will need to feed 15 people. So notice in this original fraction how the hamburger is on top and the people are on the bottom. So the 15 people, when I set up this fraction here, since I put people on the bottom of the first fraction, I've got to put the 15 people on the bottom of the second fraction as well. Do we know how much hamburger that we were supposed to use? Was that given to us? No, that's the answer to the question. That's your variable. That's what we are trying to find. So since X is in the hamburger spot, when we solve this proportion, this will tell us how many pounds of hamburger we would need. All right. So that's our fraction. We're going to crisscross these guys. So the 15 times the 4 would give you 60. And then the 6 times the X is going to give you 6X. As long as you can set them up, most people find solving proportions really easy, especially if it's not one of those quadratics. And that would mean we would need 10 pounds of hamburger if that's how many people we needed to feed. All right. All right, 2. It says a 10-foot tree cast a 20-foot long, the word shadow should be right here now that I look at this. Oh no, shadow 20 feet long. I didn't read it correctly. Never mind. Cast a shadow 20 feet long. So when we set this up, the 10-foot tree is going to make a 20-foot shadow. Eventually, you don't have to be so thorough writing all the words out. I'm just doing it so we understand that we're putting the same thing on top, on the bottom in both fractions. So when I come over here, then it says a building casts a 120-foot long shadow. Where does that 120 have to go? On the top or the bottom? On the bottom, because that's where I put the shadow in the other fraction. So since the shadow is 120 feet, that means the shadow better go on the bottom of the other side. And then the size of the tree is going to be what we are solving for. All right. Once you have it set up, again, most people handle this pretty nicely. You're just crisscrossing. 120 times 10 is 1200. The 20 gets multiplied by the x, so that's 20x. Divide by your 20. And then the x is these, what are 60. So the tree would be 60 feet tall. All right. All right. Number 3, bringing back a little bit of what we just tested on. So it says the ratio of the measures of the angles of triangle ABC is 3 to 4 to 5. Find the measures of each angle. So it just brings back this idea of if we have this triangle, all 3 of these angles here still must add up to be 180 degrees. All right. This is just giving the relationship between all of them. Whatever our common x is, so we're trying to figure out what would that be, like that common ratio. This one would be, one of them anyway, is 3 times that size. The other is 4 times that size. The other is simply 5 times that size. And then from here, we should be good. Add all these up. We should be pretty good at, what is that, set 3x, 4x, and 5x have to add up to be 180 degrees because they're the angles of our triangle. Gives us 12x. Divide by 12. 15. Now, answer this question. And then we also, as we start getting into this chapter with ratios and everything, the order is going to be important. So when you see this triangle and it says A, B, C, notice how A is first and the 3 is first. So the 3x has to be angle A. Must be. Angle B is listed second. The second number in this ratio is a 4. So angle 4, the 4x, has to be angle B. And then angle C is the third one. That means 5 corresponds to the third one. That has to be angle C. That way, when I'm asking you find the measure of each angle, if I now asked you for the measure of angle A, we know that was the 3 times the 15, which is the 45-degree angle. Angle B was again second. That was the 4x angle. So that's going to be 4 times 15. So that's a 60-degree angle. And then angle C is the 5 times the 15 degrees, which is 75 degrees. All right. So that is important. All right. The order. All right. Last one. Go all the way through that one. See if you understood what we just did. Similar, a little different, but kind of the same idea. Calculator for this too.
Such nice numbers for
I know, right?
example.
Okay, let's see where we're at here. Similar setup where you're given a triangle. So obviously we have 3 angles and sides in a triangle. You are now told that these are the 3 sides, that these are the ratios, and it's a 3 to 7 to 5. So again, we don't know what our x is, so we're going to make one of these 3x, one of them the 7x, one of them is 5x, so that they're all the same multiple of whatever x is going to be. This time, instead of the angles, though, knowing they're 180, I'm giving you the perimeter. Perimeter is just all of these sides added up. So when we add all of those sides, the 3x plus the 7x plus the 5x, that's our perimeter. And we know they better add up to equal 156.8. All right, so that should be our equation. All right. Not 180. If it was the angles, you'd set them equal to 180. All right, add them all up. So that's what 15x's equals 156.8. And this is what I need a calculator for as well. Ooh, yikes. What was I thinking here? Hold on a minute. Do you get a really ugly decimal also? Divided by 15. Ooh, that's bad news there. All right, divide by 15. That should give you, we'll go 10.5. We'll round to the first decimal place to that 10th spot. It's kind of an ugly decimal if you plug that in. And then if I want the 3 sides, this side would be 3 times the 10.5. So that is what, 31.5. That one I can do in my head. So that's one of our lengths. The other one would be 5 times that. So that's at 52.5, I believe. Yeah. And then the other one, 7 times 10.5 is 73.5, I think. All right. And then those are our three sides. All right. Okay. Oh yeah, I can see these two.